Students of Class 6 ICSE board. Today I'm going to discuss about set theory. There are some little portions of set theory you need to know about. Something like what is a set, right? And what are the different types of sets and what are the different notations we need to use in set theory. That's it. And we need to know about the definition and how to represent a set. So, first of all, what is set? What is a set? According to German mathematician George Cantor, set is defined as it's a collection of well-defined distinct objects. Well-defined distinct objects. Set is a collection of well-defined distinct objects. Some example, you need to know about this thing also. Collection of all natural numbers. You may consider this one as a set. Okay. Collection of all markers, whiteboard markers, that's also a set. Collection of all English alphabets, that's also a set. Collection of all Bengali alphabets, those are also a set. So, in set theory, it's a collection of well-defined distinct objects is known as a set. Now, we may represent as a set as a capital A or capital B or capital C or capital D, something like this. We need to use those English alphabets to represent a set. Okay, and you need to represent the elements by using a curly bracket here, and inside of it you need to write those numbers A, comma, E, comma, I, comma, O, comma, U. Those are the collections of all vowels in English alphabet system. This is also a set. Here, I'm representing here. Now, if you write this one, capital B equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is also a set because here I'm presenting 10 numbers, 10 natural numbers. Starting from 1, we are going to 10 actually. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is also a set here. And A, comma, E, comma, I, comma, U, it's also a set because it's properly defined. Look, what is the definition here? Those alphabets, which is a vowel actually, you need to consider it into this set. Okay, so A, we all know that A is a vowel, so A belongs to capital A set. E is also a vowel, so A belongs to capital A. I, O, U, similar logic for that. Okay, and here 1, 2, 3, 4, 5, 6 up to 10, those are all natural numbers, and you need to consider those natural numbers lesser than or equal to 10, and you need to consider them into this set, that is capital B. So there are some things we need to know about it. It's a collection. Definitely it's a collection. Set is a collection. You need to collect some things. We may consider collection of some numbers, collection of some real numbers, collection of some integers, collection of all planets in our solar system. Okay, collection of all cities in India, collection of all continent in total earth. Okay, so this is actually a type of collection, and it need to be a well-defined collection. That is, you can't there can't be any type of incompleteness in providing a definition here. Suppose you can't consider this one as a set, collection of all good students in a class. Okay, in your class, collection of all good students. Look, suppose X is a good student, Y is a good student, Z is not a good student. Okay, moreover, say the W is not a good student, A is a mediocre student. I'm telling this. Okay, so I'm considering that X is a good student, Y is a good student, and none of them apart from them is not a good student. Those are actually poor student and those are actually mediocre students. So that's my opinion. Actually, my opinion. I'm considering them. I'm considering X and Y as a good student, as good students. Okay, and A as a mediocre and rest one as poor students. So that's my opinion completely. Look, some another teacher comes and something he may consider Z as a good student, A as a good student, and X and Y as a poor student. I may consider that a student getting 90% and above in my examination, those are considered as good student. Okay, no problem. Those are good student in my definition, in my established definition. Okay, so it's not the same scenario in some another teacher. So he may come and say that okay, no problem about that. I don't need 90%. I just need 50% marks, and those candidates who are getting 50% and above, those will be definitely considered as a good student. Now another teacher come and say that no, there are no good students and bad students. All which are studying in my class, those are all good students. So we're getting whichever who one is getting 90% and above or 100% or someone is getting zero. Those are all good students and those are my students and those are all good students. So it differs actually, man to man it differs. Okay, so uh, collection of all good student is a not a set actually. Collection of all tall boys, that's not a set also. So you need to be specific actually. Providing a definition, you need to be specific, and and those collected well defined objects need to be distinct actually. So say there are some numbers 1 comma 1 comma 2 comma 3 comma 4 comma 5 comma 2 comma 6. There are some numbers written here. Actually there are 8 numbers, and you need to make a set here, and you need to consider 1 comma 2 comma 3 comma 4 comma 5 comma 6. You can't consider 1 again and 2 again. There are no repetitions in set theory. There are no repetitions in set, in a single set. So those are the preliminary ideas. You need to consider this one. The main thing in the definition of a set is that will be a definite collection. The collections, that the elements are actually well defined and those objects are definitely distinct. So you need to know this thing. Okay, now we're going to switch over to the next theory, representation of a set. Representation of a set. Representation of a set. Look, there are two types of presentation. First one is roster method or tabular method. Roster method or tabular method. Now, what is roster method? Roster method is something where you are writing, say A is equals to collection of English alphabets, and you are writing this one as this way, A comma E comma I comma U. That's our roster method. You are writing A is equals to maybe A1 equals to, you are writing 1 comma collection of all natural numbers starting 1 to 10, 1 comma 2 comma 3 comma 4 comma 5 comma 6 comma 7 comma 8 comma 9 comma 10. That is, you are writing those numbers in tabular notation. Okay, you need to write actually all numbers here. You need to write all numbers, all elements. In case of alphabets, you need to write all alphabets. Now, what in the case of a property method or set builder method? In property method or set builder method, you are just using one property here. Okay, look, B is a set. You are introducing a variable here x such that, this is a notation of such that symbol actually, x such that x belongs to, this is belongs to symbol, x belongs to natural number, this is natural number notation, and this is the notation of and, x belongs to natural number and x lesser than or equals to 10. That is, we are writing all natural numbers up to 10. 1, 2, 3, 4, up 5, 6, 7, 8, 9, 10. So you are writing it, those same numbers you are writing it in this way. That is, this is our actually set builder method or property method. We are just describing, we are just introducing one variable here, that is x, and x holding a property, that is x belongs to natural number and x also lesser than or equals to 10. So this is our property method or set builder method, and we just use those two methods there. Actually, first one is roster method and second one is property method. There are two types of presentations we are using in set theory to represent a set. Now, some basic definitions or basic notations, some notations, useful notations. I'm just writing it down here. First notation is, this is known as phi or null set. This is known as null set or phi. In case of representing a null set, you just need to introduce this symbol. Okay, look, collection of all natural numbers. Collection of all natural numbers where x is lesser than or equal to 1, 0, actually 0. We all know that there are no negative natural numbers. Natural number starts from actually 1. So there are no negative natural numbers. Even 0 is not also a natural number. So there are no natural numbers in negative zone or 0. So this set is actually a null set or empty set or void set. So you need to represent this one as phi. This is phi actually. A set containing no element is known as a null set or empty set or void set. Okay, void set or empty set or null set. That's it. Now, what is a singleton set? Singleton set, in case of a singleton set, a set consisting of only one element or a single element is known as a singleton set. Look, this one is a singleton set consisting of only one alphabet, that is B. It is a singleton set. Okay. Now, this sign is used to represent belongs to. Okay, belongs to symbol is this. Now, what is this symbol? This is such that, this is such that is represented by also this symbol. This is also such that. Okay, this one is known as and this one is known as or. So actually, you don't need to know about the other notations of. You don't need to know about other notations from set theory right now because you are too bad. Okay, you're just studying in class 6, so you don't need to know about all the details about set theory. You just need to know these things actually. So we need to know one more thing, that is cardinality. That is cardinal number of a set. And what is a cardinal number? Cardinal number of a set is cardinality or cardinal number. Cardinal number is representing the number of elements of a set. That is, if a set consists of 5 elements, a, e, I, o, u, then number of a set, that is number of elements in A, that will be 5. If we are getting capital X equals to 1, 5, 10, 11, 13, 16. So there are 6 elements. So number of X, that will be 6. These are the things actually. Now, what will be the next topic? Next topic will be some basic set theoretic applications or rules we need to follow. First one is union. Now, what is union? In case of union, A union B, that is represented as A union B and defined as X is an element where X belongs to A or X belongs to B. That's our A union B, where A is equals to 1, 3, 4, 5 and B is equals to 3, 5, 7, 9. So, A union B is defined as X such that X is an element where X belongs to A or X belongs to B. That is, you need to consider those elements which are in A set and also in B set and in both set also. So, we need to consider 1, 3, 4, 5, 7 and 9. We all know that there are no repetitions in a set. So, you can't write 3 and 5 for 2 times or double time. Okay. You need to write those things for a single time. Okay. So, there are actually 6 elements. Now, what about intersection? Intersection, in case of an intersection of 2 sets, it is represented as A intersection B, this notation. And the definition is X such that X belongs to A and X belongs to B. That is, you need to consider those elements in A intersection B which are in A set and B set simultaneously. Okay, now you can see that there are 2 numbers 3 and 5, both belongs to 3, 5, both belongs to A and B actually. So just write down 3 and 5 here. So that's our A intersection B. Okay, so that's some basic theory you need to know about set theory. Okay, so in our next part of the video, I'm going to do some problems here. Okay, so just follow the video and just brush up your theory part. Okay, I think there will be no confusion. If you have any doubt or question regarding set theory, just give me a comment in comment box and I will definitely be there with you. So if this video is fruitful for you, then just like the video, press the notification bell and share this one with your friends. Thank you. I'm coming with the next part very shortly.